So let's move to the next problem here, which is very closely related to the previous problem. You are given two arrays, um, array 1 and array 2. So let's say this is array 1 and array 2 is, maybe I should draw it here, because array 2 is supposed to be double the size of array 1. So if this is array 1, this is array 2. So if the size of this array is n, the size of this array, the second array is going to be 2n, but um, the the numbers that actually fill in the values that we are interested in are such that the first array is completely filled in with values that are sorted in increasing order, and the first half of the second array is also filled in with values that are sorted, and it's assumed that the second half has empty space in it. So there's nothing really stored here, even though it's part of the capacity of the array. And what we need to do is to merge these two sorted subarrays together such that the final output, such that their overall merged output exactly lies inside the second array. Okay, so we want to create the merged output within the second array, not in some auxiliary space outside both of these arrays, since the second array has the capacity to hold all of the merged output. So uh, an example here uh, that's given here is the first array has, let's say, the numbers 1, 3, 5. Second array has numbers 2, 4, 6. So in that case, assuming that these zeros are just, empty space, they're not meaningful values, we naturally want the merged output to be 1, 2, 3, 4, 5, 6, and exactly filling in this space here. So this, at least in my live class, is a problem that is typically assigned after part 2 is over. There's a corresponding lead code version of it. I think it's called merge sorted array, or the title is merge sorted array on lead code. So the problem that you encounter when you try to merge these two arrays in the regular order is that you can't really store the values back in the second array, because again, as more and more values from the first array need to be squeezed into the second array, you have to basically right shift all the elements uh, back in order to make space for those merged values, which is obviously going to cost time. The goal is to do this in linear time, order n time. And since time is short, and I assume you've already done this, either you were given this as part of your first week test, or as operations is doing it more recently, this is part of the practice set 1 itself. There was no separate test in week 1. So since we encounter an issue when we try to find out the smallest element and then insert it into this spot, because we might have to right shift everything, the way to solve this problem is to think in terms of the opposite end, that is, focus on the largest number rather than the smallest number. Right? Suppose I decide as a lazy manager, I'm just going to figure out what the largest number in the merged output is and put it in its right place. So what's the largest number going to be? It's going to be whichever number is the bigger among these two values, and the correct spot for it is the rightmost place here. Once I've done that, then I can hand over the problem to a subordinate who can then try to figure out what the second largest number is going to be among the remaining numbers. Right? So assuming that we have 2 pointers that can tell us what that can mark the boundary of what the remaining numbers are or where they end, we can keep picking, each manager can keep picking the larger among these two values and put them into uh, the next available slot from the right end. And so the merged output gets created in this way from right to left. And so the code for this is going to be very close to the code for merge sort. We have the initialization part, right? We are not sorting, we're not doing the complete merge sort here. We are just doing the merge phase. So in the merge phase, remember the code starts out with an initialization phase, and the initialization of I and j is going to be both n minus 1, right, where n is, you can say, the length of the first array, length of array 1. So those are the two indices, and since the auxiliary array is the same array, we will need to know where exactly in the second array do we insert the next output, the next element to go in the merged output. So we'll have an index k again, like we did in the the implementation of merge sort that I talked about a few minutes ago. So k is going to be, it's going to start out being 2n minus 1, right? Or you can say length of array 2 minus 1. So that's the initialization part. And then we have our while loop. While the I pointer is pointing within the bounds of its array, while the j pointer is pointing within the bounds of its respective array. That means while, as long as I is greater than or equal to 0 and as long as j is greater than or equal to 0, we have to do something, right? So maybe this is where the I pointer is now. This is where the j pointer is now. We are going to pick whichever is the larger number and put it uh, wherever k is, right? So if a of I is, sorry, not a, if arr1 of I, array 1 of I is less than or equal to array 2 of j, right? That means the number in the second array is bigger. That means that's the number we're going to copy into the merged output. So we will copy it. Of course, the auxiliary array itself is array 2. It's not a separate array. So at index k, we're going to copy the larger value. And we're going to decrement k as well as decrement the j index. And in the other case, where array 1 has the larger value, we will copy that into the second array at that same index, decrement the second index as well as decrement the I pointer. We keep doing this until one of the two arrays jumps off the legal boundaries of its array. So if I or j jumps off, remember the pointers are going left here instead of going right because we are starting from uh, the right end. We are picking the largest value uh, uh, iteratively, and so our pointers are moving left. Um, so if the I pointer jumps off its left edge, then the j pointer might still be inside, and if the j pointer jumps off, the I pointer might still be inside. So we again need a gather phase to gather together the numbers in the other array, right? So let's say the j pointer jumped off. That means we need to collect the remaining values from the first array and add them to the merged output. So uh, if the first pointer, if the I pointer is still pointing inside, we need to gather array 1 of I and put it in array 2 of k. Right? Again, we are doing the same thing that we were doing here if one of these conditions is true, followed by k minus minus and j minus minus. Oh, sorry, I. It should be I. Array 1 of I. Array 1 of I. And then I minus minus. Okay, we are gathering the elements from the first array here. Now, there will also be a gather phase. I mean, ordinarily, people would also have written a piece of code like this: while j is greater than or equal to 0, we gather the elements from the second array and put it into the auxiliary array. It so happens that, if you think about it, any elements to be gathered from the second array are going to be put back into the same positions as they already are, because we know that the, the input has been given to us in a way that we will have exactly 2n elements filling up this array, and so eventually our k pointer has to end up at index 0. So whatever remaining elements there are to see, if they are all from the second array, then those elements are already where they should be. So we don't need a gather phase for the second array. Okay, so this is not needed, and so once we gather up the elements, any remaining elements from the first array, the output is already there in the second array, and it looks like you don't have to return anything in this problem, and so that's it. We just change uh, the array in place, the second array in place. Okay, so that's what we do over here. Um, we just check if this runs. Yeah, looks like it's the same. Okay, any questions on this? It's, yeah, Dinesh.
Yeah, so here J is the bigger array, right? So I will never come out without being 0.
Uh, well, it's not just the size that matters. If you actually see the number of elements, they're actually the same in both that we are merging. But even beyond that, it really depends on what the values are. Right? If all the values here are larger than the values there, then all of these will be moved here, and then we'll have a bunch of values to gather from the first array. Right? Because if these values are larger than the values here, then the j pointer will be rapidly walking through the second array up to the front, because we'll continuously pick the larger of the two values pointed to by the two pointers, and so we
Yeah,
preferentially pick up these larger values, and that will leave us a lot of elements to gather
yeah, yeah.
the
It
first
just
array
depends on how many elements are in each array.
and their values,
Yeah.
their relative values.
Thank you.
Mojgan.
So I was going to ask how about array wasn't sorted?
Yeah, it's already given to be sorted in ascending order. Both arrays are sorted in ascending order.
Yeah, my
Uh,
question, how about if they were not sorted? How do you
yeah,
do?
so then you would have to basically sort them and then do the merging.
Oh, sort them separately. Okay.
Yeah.
Thank you.
Or you could just directly, you know, just put them into the second array and then sort the second array directly. But that wouldn't be a very interesting problem because, you know, this is interesting because you have to think of this trick that instead of picking the smallest element, instead of doing decrease and conquer from the left end, let me actually make the decision for what the largest element should be.
Yes.
Put that there, and then keep going that way.
Yes. Thank you. Can I ask another question, although it's
Yeah.
not completely related? I was wondering if you can help us with some math algorithms.
Math algorithms of what type? You mean the ones that are tagged math on lead code?
Yes.
Yeah, so there are obviously a lot of subtopics that are still left to be covered. So I'll be covering them uh, piece by piece. So I'm actually trying to see if I can get an intern in the summer to actually work on the math problems. Uh, I know someone. She's really good at, you know, she's been doing competitive programming beyond lead code and also um, um, giving the national AIME and you know, preparing for the international math olympiad. So I'm trying to see if someone like them could come in to solve those math problems, because there are already too many topics for me to uh, cover, and so this will take forever if I have to do everything.
Okay.
But yeah, I'll keep that in mind. Thank you.
Thank you. I appreciate. Thank you.
Narendra.
Yeah, Omkar. So the key to this problem solving is to identify the sort based on the bigger element, right? So is there any other problems we can correlate to think in this direction? Is there any
I
other
would say
problem
that the
statement say
thinking, yeah, the thinking, you could say that so the direction of thinking was just that I have a hard time figuring out what the smallest element is, which is really the default way in which we do decrease and conquer, to figure out what the leftmost element should be. But here, because there is no space at the leftmost end to insert the
right?
leftmost element if it comes from the other array, and so because there is space on the right end, the insight is, let me figure out what the rightmost element should be, and so that's
Got it. Yeah.
the technique. So I would not say it's picking the largest number. I would say it's doing decrease and conquer from the right end. That's the way I look at it, instead
Right,
of the
right.
left end.
So is there any other similar problems or any other things that we can correlate to use this kind of pattern?
Uh, I can't think of one at the top of my mind right now.
Okay, sure. Yeah, but yeah, got the point. Thank you.
Sileni?
Hi. No, I was just going to, and it's not something for today. I've been looking at doing some division and multiplication with very large numbers.
Mhm.
So I was just wondering if maybe, for the future, soon though, if we could have maybe a problem like that.
Okay,
Uh,
you mean, yeah, large integers. Yeah, so
yeah.
that's part of the to-do list. I guess it would come under the math category again.
And I
Uh,
guess it would be using some bitwise operators, right? So I don't think
yeah,
we covered much of that either, right?
yeah, that's also one of the to-do topics for me. Yeah,
Just a suggestion. And you're so good that I know you always have room for more knowledge there. So
sure. Yeah, I mean, it's part of my to-do list. As I said, I'm just going to go in some priority order as well as ease with which I can uh, cover things. If I think I can go faster on some topics, I might pick those up sooner.
okay.
But yeah, I will get to bitwise operations as well. That's also part of the agenda.
Thank you. This has been good to have this review. So
Thank you. Ajay?
Yeah, Omkar, I just want to add, like, whenever I here I got a question like sending sorted order of the integer. So always think like, okay, let's go from the backside. I mean from the end side. So means I don't have much questions, but I'm thinking, always thinking like if we started already, so let's go from the end side actually, not from the starting side. So is it okay? I mean,
Yeah. I mean, you can do decrease and conquer from either side, right? You can do it from either side. Here, this is a rare problem where um, you have to do it from the right side. So if you're not used to doing it from the right side, then you need, it takes a little more effort to think about doing it that way.
like link, let's suppose there is a two link list, merge two link list, sorted two link list, and you can start from the end.
But for linked list, you will have to start from the left end because I mean, unless you use some kind of recursive procedure where you go all the way to the end and then you start merging from the right end. But if you were to just do a straightforward iterative approach, you would merge them from the left end, right? Analogous to these 2 pointers.
Okay, no problem. Yep, thank you.
Syed.
Yeah, hi there.
Yeah, hi.
Can you hear me? So
Yeah.
I was just curious, like I was thinking if question is a little changed, like instead of the integer data type, it is provided like with like a character or in that. So it shouldn't be that much change, probably, I think.
Yeah, it doesn't matter whether it's integer or
Like in
character.
terms of character, and then we just need to change, convert into the integer, the number of like the ASCII code, probably if it's ASCII codes.
So here we don't really we don't need the ASCII codes. If they were characters, we could just check whichever is the larger character. So typically in these languages, if a character comes later in lexicographic order, the comparison would automatically, I
Convert
guess, look
into
at the ASCII code
ASCII
under the
codes,
hood
yeah.
and figure out which is the larger character.
But I don't think that kind of questions ask or tweak in terms of
Yeah, although again, character encodings are also part of the to-do list. So understanding how integers are represented, 2's complement and notation,
correct, yeah.
and character encodings, ASCII, Unicode, UTF-8. So
Yeah.
that's also part of the of my to-do list.
Well, thank you so much. Yeah.
Sure. Dinesh, you had something else?
No, I'm sorry, I forgot to lower the hand.
Narendra?
Yes, Sankara. My question got answered. Maybe I need to lower the.
Okay, sure. Sileni?
Yeah.
Yeah, I had one more question. I've been a little stuck on doing the palindromic permutations, and I keep getting the time limit exceeded. So maybe for a suggestion, and I might just get into a coaching section and have somebody discuss that with me too. So,
Sure. Is that from the recursion set?
it's a lead code problem that I've been trying to do.
Okay. Yeah. So you can take it up with the coach, one of the coaches, and if you don't get the solution, you can, just ping me.
Okay. But how do we ping you?
On Discord, you can just ping me on Discord.
Okay.
If you're on Discord, you can just tag me on your channel or just send me a direct message.
Okay, I'll do that. Thank you.
Bhatia P.
Yeah, I had a question. If you have like something like a mix of inputs, like array 1 has 2 elements. Actually, it should be like array 1 is 1, 2, 8, 9, and array 2 is 4, 5, 6, 7. Do we still need to not check the final if one? I'm wondering if the K will be exactly in place to allow you not to check for the, you know, for the final if condition, something like this.
Um, so here 9 will go first,
Yeah,
right?
9
9 will
and
go
8 will.
first, then 8 will go, then
Uh,
7 will go, and then 6.
and where is the K? K will K be here? K will.
Yeah. So when I say 9 will go first, I mean 9 will go at the right end here.
Right, right.
Then
Then
8, then
then
7.
then it will 9 will be going. Then 7 is still left. 7 and 8 will be compared, right? In the next
Yeah,
iteration,
yeah. 8 and 7 will be compared, then 8 will
right?
go.
It will go in.
And then
Then
7 and 2 will be compared.
right.
7 will go. 6 and 2 will be
7.
compared. 6 will go then. Then 5
Right.
and 2 will be compared. 5 will go. 4 and 2 will be compared. 4 will go.
4 will
And
go.
then at that point, we know that, we need to gather up the numbers from 2 onwards from the first array. So that's what we
Okay,
will get.
okay, okay. Right, right. So in this case, we have gone over the second array first. Right.
Yeah,
We've gone off the left edge of the second array. Okay.
right. Yeah.
Okay. So I was just trying to see if that case where you don't have to check if that you have that you've
Well, you
gone
can
over.
just swap them, right? Just make this 4, 5, make this 1,
Yeah.
2. Then
Right.
what
Right.
you will have is when you're done with 9 and 8, uh, you'll compare 7 and 5. 7 will go, then 6
Right.
will go, and then 5 and 4 will go, after
Four.
which you would have jumped off this array, and then
Right.
1 and
Right.
2 are already in place.
Okay. Okay. Right. Okay. Yeah, I think, yeah, I was just trying to see the situation in my mind, how strong that situation is. So I think, yeah, it would probably hold good.
Yeah, I mean, because K and J have to end up in that situation, K and J will coincide, because whatever elements there are left to gather from the second array,
Right.
those are all going to go at index K, and we know that index K is going to end exactly where J ends. So at that point, they are literally coinciding. So there's no point in doing that
Okay.
explicit gather phase.
Okay. Okay. And everything that is larger in I is already back in the back of array 2.
Yeah,
So we don't have to worry about it. Okay. Those two leftover elements have already been compared with I. Basically, that's what I'm
yeah, yeah.
saying. Yeah, already have been compared. Okay,
Right.
fine. Okay.
Okay. So let's proceed ahead now. Okay, just one last question, Priyank.
Yeah, so Omkar, this question is a bit generic. So I'm just confused about my preparations. Do you think that solving the questions in problem sets for all the topics that we have and whatever questions are covered in the live sessions that we have or floater sessions is good enough practice to cover like most of the patterns in interview, or you think that we should go again and look at lead code problems also?
So I think you would cover more than 200, around 200 to 250, maybe a little more, if you go through all the problems in the uh, practice set and the floater sessions. So after that, there might be, depending on what company you're interviewing in, it would still be worth to look at the top 50 or top 100 questions at that company, most of which should have been covered, but there might be a few that are not, just because there are some topics, some long tail topics that we may not have covered, and there might be, one or two questions from there which are very popular. So I would say in the final few days before the interview, you should look at the uh, high frequency problems on lead code for that company, at
Yeah.
least until we have covered uh, most of the remaining long tail topics that might take 6 months, 5 to 6 months more. After which those problems, almost all of them might automatically be there, but still I would personally recommend just looking at them.
Okay, but you think that solving the problem sets and whatever are covered in the live and floater sessions, that is good enough practice for let's say 90% of the problems.
Yeah, 80-20, if you follow the 80-20 rule, I think they should cover 80% of the problems. And obviously within the next few months, over the next several months, that percentage will increase, maybe beyond 90 or 95.
Yeah, I got it. Okay, thanks a lot. This question has been there for so long time in my head.
Sure.
How to go about it. Thanks for clarifying it. Thank you.
Okay, so having done the two problems related to merge sort, let's now get to the other two problems which are related to quick sort.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today